Hey gang, and welcome to the Worksheet Solutions walkthrough for Say My Name, IUPAC, Alkane Nomenclature. So, if you're new to this, or if you already know the drill, you're here because you've seen the instructional video of IUPAC, Alkane Nomenclature on jOeCHEM. You maybe have done the worksheet, looked at the answers. Maybe you're confused, you want some more detail. Well, you're in the right place. We're going to be doing the worksheet, we're going to be doing a whole lot of naming, so buckle up, let's do it. Okay gang, so in problem one, we do my personal favorite type of naming questions where you are given the name and you just have to provide the structure. I like this because it's like mentally easier than just, numbering, alphabetizing, putting the name together. You just give the name, you just do a little zigzag and you're done. Okay, so and I know I don't have 5, I'm just gonna go ahead and make some room at the very end and do letter V. Okay, so in the first one, what I like to do, the way I tackle these is I always just draw my parent chain every single time, and then I just fill in the substituents after that. So here we're dealing with a hexane, so that's 1, 2, 3, 4, 5, 6 carbons, and then just go through the name until you hit the parent chain name. So 3-ethyl, 1, 2, 3, so an ethyl group, 1, 2. And 2,4, we have a dimethyl, so on 2 we have a methyl, 4, 1, 2, and I'll make this a little bit bigger, 1, 2, 3, 4, a methyl right there, voila, easy, right? Okay, second problem. We have an octane, so that's 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. So on 5, 1, 2, 3, 4, 5, we have an ethyl. On 4, and here's where our knowledge of common naming comes into play, we have isopropyl, 1, 2, 3, 4. So remember, it's 3 carbons, and we are attached at the middle. So you can see 1, 2, 3, and then we're attached that middle carbon to the parent. So again, common naming, already paying dividends for putting in the effort. 3, 3, 3, 6, trimethyl. So 1, 2, 3, we have not just one methyl, but a second, 2 methyls on 3, and then 4, 5, and 6. Done. Okay, so now, this one was easy, but I kind of wanted to sneak a little bit more common naming in here. So we have 2-chlorobutane. So butane and a chloro, okay? Now, what's the common name here? And I hope you are already on top of that. Remember, so it's not just butyl chloride or N-butyl chloride, it's sec-butyl chloride. And funny enough, even though I just wrote that down, I'm going to make some space for 4 by erasing 3. And I'm going to erase 2 as well, just to make room for letter V. So, erase these. Okay, so for 4, we have 5 I'm already abandoning my own process. Decane, right? So that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on 5, 1, 2, 3, 4, 5, we have a bromo, and of course I didn't give myself enough room. There's the bromine. 6, T-butyl. So remember, so here's 5, up here's 6. We need 4 carbons off of this. So 1, 2, 3, 4. 1, 2, 3, 4. That's T-butyl because we're attached to what is the tertiary carbon in isobutane. You can also think of it as just being like a turkey's foot, or some people will also draw it like a cross just because they don't really, they're just going fast. So don't be thrown if you see it like this, or bent like, that turkey's foot, or like someone holding up an ugly 3. So then 3-ethyl, 1, 2, 3, we have ethyl. 2, 7, 8, trimethyl. So 2, 1, 2, 3, 4, 5, 6, 7, 8. And that's it. So you can see, I hope you're getting, or even when you saw this section, you realized, when someone gives you the name, it's really not bad. And last but not least, let me do letter V, 5 Roman numerals. Okay, so this one is also another one I wanted to sneak in there. It's 1 iodo, 2-methylpropane. Okay, so propane, 3, 1 iodo, it's an iodine right there, and 2-methyl. So I hope you're thinking, silly, right? You name this structure like this if you're kind of an organic square. I'm not trying to make fun, but I'm totally kidding, by the way. It's a totally valid name. However, if you just wanted to do it a little bit more slickly, you could call this isobutyl iodide. Okay? So gang, that does it for section 1. I hope you realize that when you're given the name, you just follow what you're given, you just create it, and that's that. All right, on to problem 2. Okay gang, so for problems 2 and 3, I'm going to do one example at a time just to save space and make sure I can give the best explanation for each one of these naming things as possible. Okay? So, we are given this structure. So remember our first priority. Find the longest chain. And take your time. It's all too easily, and I was guilty of making this mistake too, of we're always biased to go left to right, at least, you know, for my English speakers out there, just because that's how we read. So make sure you evaluate all the various ways that you can count for the longest parent chain, okay? So we have a few options. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, I'll put a little 11 up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We roll 11 right here. 1, 2, 3, 4, 5, 6, not a big deal. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Shorter than 11, doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Too short. So I don't think there's any other combinations that would give us anything longer than that, even though I did do it left to right. I was trying to make sure I went various routes and things like that. So we have a tie, right? And the way we decide ties, when we have the same, different routes that have the same length for the parent chain, is we go with the route that has the most branching, but at the lowest number. So we're not going to count from right to left because we don't hit a branch 1, 2, 3, 4 until 4 going this way. So we're really looking at these two routes going left to right. 1, 2, 3, a branch at 3, or 1, 2, a branch at 2. So it's in fact that we're not going with this route, we are going with this route. So I'm going to number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so now that we've identified the parent chain, and we had to break a tie, that's not always the case, but we did. Now we can just go ahead and, I like to number my substituents, then I want to alphabetize them, and then I want to actually produce the name. And that's how we'll go about naming any of these structures, right? So, you can see at 2, we have a dimethyl. Now, since I just started with 2, and I see I have methyls, let me see if I have any other methyls in my structure. And in fact, I have one at 5. So I have a 2, 2, 5, and I have 3 of them, so that's a trimethyl, right? So that's one substituent. At 3, I have an ethyl, and that's the only ethyl I have, so 3-ethyl. I already took care of 5, nothing on 6. Oh, and I caught myself. See, I added, a methyl at 7. So instead of this, it's actually 2, 2, 5, 7. 5, 7, and it's tetramethyl because we have 4 of them. So, nice part about naming is that you can always correct yourself as you traverse your structure. So at 7, we do have a bromo. Okay? Then 8, remember, common naming, we have 1, 2, 3 carbons, we're attached at the middle, that is 8 isopropyl. Let me just verify real quick that I got all these, because sometimes when you're doing them on a worksheet and you're doing it in front of a camera, you make mistakes. So, yep, looks good. So now we need to alphabetize, and there are some rules here, which is unfortunate, and you can make some mistakes, which is kind of annoying because we've already done so much hard work. However, remember, when there's no parentheses, and we will get to examples with parentheses, those, the di, tri, tetra, penta, blah, 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 those prefixes do not count towards alphabetizing. However, things like iso, cyclo, those count. So if we take a look here, what I like to do is just underline the letter that counts for the alphabetizing. M, E, B, and I. Remember, the T in tetra doesn't count because that's one of those prefixes that just doesn't count unless it's in parentheses. We'll get to that example. So, Now, the hardest part, remembering the alphabet. So, bromo takes the cake with 1. Then we have ethyl with 2. Then we have iso with 3. Bringing up the rear is the methyl, okay? So remember, so the rules are between numbers you do commas, and then between either, if it's number letter or letter number, it's hyphens, okay? And our parent chain is an undecane because it's 11. So to string this all together, we do have 7 dash bromo, right? Because we have number, letter, and now since we're going to go from letter to number, it's 7 bromo, then it's going to be 3 ethyl. Just trust your alphabetization. Hard word to say. 3 ethyl, and then we have 8 isopropyl. Make sure you have enough room to actually write this long enough. 8 isopropyl, and then again, we're going from letter to number, so then it's going to be the 2, 2, 5, 7 tetramethyl. And then when you go from last substituent into the parent, run it all together. Sounds super weird, but run it all together. Tetramethyl undecane. Okay. Take it in, and then we'll move on to the next example. Okay, gang, so now we're on example 2 of problem 2. All right, so if we take in this magnificent structure right here, first objective, always the first objective, find the longest parent chain, okay? And remember, just evaluate as many options. Be superstitious. Make sure you count all the routes, because the worst is when you don't give yourself a chance to get a naming problem correct because you picked the wrong parent chain. Okay, so, what I like to usually do, and you don't have to have this thing to remember at the very beginning, I usually start at places that have a lot of branching because that means I'm usually on the right track. However, evaluate all the routes. So 1, 2, 3, 4, 5, 6. That looks way too short. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 is pretty long. And if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it doesn't matter. This is kind of like a turkey's foot, so it doesn't matter if you go this way, or this way, it's all 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 12 is looking to be our go-to number. Now, if you're wondering, what about the ring? With naming, if you have a ring, you can't include the ring in your parent chain. The ring either needs to be the parent chain or the ring is a substituent. So really we have the option of picking a chain like this where we have some substituents off, or we have this ring where we have one giant substituent. Clearly what we need to do is just pick the chain and name this ring as a substituent. Super easy. Okay, now the real question is, are we going left to right or right to left? And I hope what you're thinking is we need to see where we have the lowest first branch. 1, 2, 3, 4 versus 1, 2. Clearly we're going from right to left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So in my mind, the hardest work is done. Now the rest is more following a procedure that can sometimes be tedious. So we need to name our substituents. I'm going to do that over here. So we first have, if we look, we have some methyls, and it looks like we just have 2 right here, nowhere anywhere else. So we just have 2, 2, and since there's 2 of them, that's dimethyl. Okay? 3, that's a cyclohexane, so what we can do is we can do 3 cyclohexol. Just add a Y out. No big deal. 5 ethyl. Sorry, I kind of ran that together. No other ethyls. 6, common naming. 1, 2, 3, 4, but it's not 4 in a row. It's 4 in one of those interior carbons. So this is actually 6 sec-butyl. So that's right. You do sec and then -butyl, and that's the only time you're going to do a hyphen like that between letters and letters, because even when we named regular things, it was always sec-butyl or T-butyl. So don't be confused by that. And then 9, again, common naming, showing us why we put in that hard work. That's an isopropyl, because there's 3 carbons, right? 1, 2, 3 in the middle. All right, so remember, now alphabetizing. So remember, none of these are, we have no parentheses. So my die, whatever prefixes don't matter. M is what matters here. Now remember, it's iso and cyclo that do count. So here I have the C that counts and the I that counts. Sec and T or tert do not count unless parentheses, right? So B counts and E counts. And my chain is a dodecane, since we have 12. Okay? So if I'm going to do my numbering, B comes first in the alphabet here, so we have 1. So then we have C, we have cyclo. So then we have the ethyl for 3, the iso for 4, as well as this for 5. Let me just double check that I have all my substituents. Oh, I am now realizing I made a tiny mistake. And I blame the font I use on my computer. This is an I. Doesn't change a whole lot. This is just 2-methyl. I apologize, gang. This is 2-methyl. This is 2-iodo. I sincerely apologize. So things will change a little bit right here. The methyl is actually last. So then this is 4. Sorry, I was doing the alphabet in my head. This is 5. Let me just verify that's right on my sheet down here. Yes. So I apologize. Nothing else changed about the process. The process still good. I just forgot there was a little I right there. Okay. So now let's produce the name. So we start off with 6-sec-butyl. 6-sec-butyl. 3-cyclohexyl. And then 5-ethyl. That's a hyphen. And then we have 2-iodo. And we have 9-isopropyl. And then we have 2-methyl. And then run it all together with the dodecane. Make sure 6-sec-butyl, 3-cyclohexyl, 5-ethyl. Yep. Okay, gang. So this, again, following the process, find the longest parent chain. If you have to break a tie, break a tie. Make sure you're numbering from left to right or right to left appropriately. Name your substituents. Don't miss anything like I did. Alphabetize, put the name together. Going forward, what I'll do is I'll name here, I'll stop the video, I'll write the name, and then I can just explain it. You don't have to see me watch it, or watch me draw it. Okay, last example in problem 2. Okay, gang, we have a short one to round out problem 2. Okay, so remember, first objective, find the longest parent chain. So if we take a look here, we got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to be an 8 of some sort, and the 8's going to either go, we have 1, 2, 3, 4, 5, 6, 7, 8, or we have the ability to go up here as well. Now, think about this. We can go 1, 2, 3, hit a branch, 1, 2, 3, hit a branch, or we can go 1, 2, and hit a branch. So the chain is actually going to be 1, 2, 3, 4, 5, 6, 7, and 8. So I like this problem just because the T-butyl is almost drawn as a substituent, but it ends up being part of the parent chain. So again, this is a pretty small one, so you know the drill. We found the parent chain, the longest one. We had to break a tie. We did it by, we saw the lowest branch, the branch get the lowest numbers. Now we just name or name the substituents, pronounce it correctly, alphabetize, put the name together. So we have 2 methyl groups at 2, right? 1 and 2, and then 1 at 6. So we actually have 2, 2, 6 trimethyl. Then we have 5-chloro. And I even forgot about 3-ethyl. This is 8, so we have an octane on our hands. And I know I said I'd pause the video and write the name, but this is a pretty small one. So chloro is our first right? So we got this, this, and this. Remember, tri does not count, no parentheses. So chloro, ethyl, methyl. So the name we're putting together is 5-chloro, 3-ethyl, 2, 2, 6-tri-methyl, run it all together, octane. Okay, gang, so I feel like some of these examples were just strong foundational examples, testing your knowledge of how to do IUPAC alkane nomenclature. In the next couple ones, turning it up a notch, so let's do it. Okay, gang, so in these next 3 examples, I wanted to turn up the difficulty a little bit. So let's get started. So in this problem, remember, we've taken the same mentality and approach that we always have. Let's find the longest parent chain. Okay, so we have a couple different options here. Let's evaluate them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9. 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's possibility 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 is looking to be a strong contender here. 1, 2, 3, 4, 5, 6, 7, 8. 1 short. I don't think I see any. Obviously, I can count the back the other way, but 9 seems to be our longest. Now, we have 2 options here. We can either start from here or here. Now, just even from this direction, I think we can both see that we first branch off at 1, 2, 3. We branch off here at 1, 2, and not only that, we have 2 branches. So, goodbye, and it looks like our parent chain is going to be from here to here, because 1, 2, 3, 4, 5, 6, 7. Since we have a fork in the road, there's 8, 9, and there's 8, 9. But we have no branching, and we have a branch at 8 here, so we win out that way. And for those wondering, well, what if we have to count from right to left? Well, let's think about this, right? If either way, 1 in, we have 2 branches, and then we have 1 branch. So left to right is our way to go, not right to left. So now that we've identified the parent chain, now we can start naming. So I think we can see we have 2 halogens, right? We have 2 halides. We have 2 chloro. We have 2 bromo. Okay? And then 4, don't jump to name that in parentheses just yet. Remember, we have a common name for that. We have 1, 2, 3, 4 carbons, and we're attached to one in the interior. That is 4-sec-butyl. Okay? And then we have a methyl at 5, we have a methyl at 8. We do 5,8-dimethyl. And then at 7, our last substituent is ethyl. Double check I didn't miss anything. 1, 2, 3, 4, 5. Yep, got everything. So let's alphabetize. I'll pause the video and then put the name together. So, taking a look here, bromo B clearly takes first as far as name, the alphabetization. Then we have chloro. Oh, I apologize. Nope. See, alphabet is hard. So bromo is first, and then we have butyl for second. Then we have chloro. And then we have ethyl, and methyl always seems to come in dead last. So I'll pause the video, show you the name, and we'll move on. Okay, gang, so remember, the reason why butyl came in second is because sec doesn't count, right? Second terp do not count. We had a no-name parent chain, so 2 bromo, 4-sec-butyl, 2 chloro, 7-ethyl, 5,8-dimethyl, no name. Okay? 2 more, and this worksheet is done. Okay, gang, so now we're getting to what I think are the more interesting examples, 2 and 3. So remember, same approach. Let's find that dang parent chain, the longest one. So if we take a look here, we have quite a few options to count, right? So we could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 straight across. 14 is pretty long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Also 14. So I'll do a 14 here and a 14 here. Maybe I'll do it that way. We could also do 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2 short. We could do, I feel like those I feel like this route and this route are our two longest paths. However, we have a tie. So we need to make sure we break that tie and then we figure out if we're going left to right or right to left. So left to right, right to left. Okay, so let's start on this end because I see a branch at 2 and a branch at 3 and I don't see anything branching, I see a branch at 2 here, I see no branch there, so I believe we'll be starting on this end and going one of the 2 ways. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, fork in the road. So the rest of the way there's no branching, and up here we are branching. So goodbye, this route, 11, 12, 13, and it doesn't matter if 14 is there or there, it's the same, okay? So now we are going to name our substituents. So let's start off with 2-bromo. We only have 1 bromine, so 2-bromo. We have a methyl at 3, so we have a methyl at 3, a methyl at 7, and a methyl at 13, so that is 3, 7, 13 trimethyl. Okay? Now at 6 we have an isopropyl. That's the only one. So 6 isopropyl. Sorry if my handwriting's a little sloppy. At 7 we have also an ethyl. And at 11 we have a propyl. I skipped 10 on purpose, you'll see why. So 11 propyl. Okay, so now 10. We have nothing to call that straight up. So I like this example because we're going to be naming in parentheses. So what I like to do is I kind of like to section this off, kind of in parentheses. So remember the rule of parentheses. We're basically naming inside of a name. So same deal, find the longest chain, do your branching, chain, direction breaking if you have to. So you automatically by default give the first carbon attached to the parent a 1. So we can either 1, 2, or we can do 1, 2, and 3, which is what we're doing. And so that means our name starts with 10, and then you have a parenthesis, just one of the 2 parentheses right there. And then you just name this thing. So we have 2 substituents, they're both methyls. So you can do 1, 2, dimethyl, and then your parent is a propyl, right? However, it's not, it's not gonna be dimethyl propane, it's gonna be dimethyl propyl because we're still a branch at the end of the day. We're just doing a name inside of a name, okay? So that's how you handle parentheses. It's super easy. It always seems very daunting when you're like, oh no, I have to do naming in parentheses, but it's always never that bad, okay? So now we need to alphabetize, and then I'll pause, put the name together, call it a day. So the interesting part here, so the B in bromo counts, the M in methyl counts, the I in iso counts, the E in ethyl counts, the P in propyl counts. However, here is where, di, tri, tetra, pento, what have you, never counts except in parentheses. The very first letter always counts. So here, the D in dimethyl counts, okay? So if we're going to use our wonderful knowledge of the alphabet, bromo will come first. Then we will have, oh, and here I go. I even forgot 4-chloro. That comes second. And then we have the ethyl takes the cake with, or no, I apologize. The D for dimethyl propyl takes 3, 4 for ethyl. See, it's hard to do the alphabet when you're recording. And then for 5, we have isopropyl. And then for 6, we have the trimethyl. And then last but not least, bringing up the rear at 7, P for propyl. Let me pause this, put the name together, but we have 14, so this is a tetradecane. So getting up there a little bit with our alkane parent chains, we're flexing our alkane nomenclature knowledge. Okay gang, here's the name in all of its glory. First we have the 2-bromo, then the 4-chloro, and then be careful here with the parentheses, right? But treat those parentheses as just letters. So of course we do 10 hyphen, first opening parenthesis, 1, 2 dimethyl propyl, and parenthesis dash, hyphen, 7 ethyl, yep, 6 isopropyl, 3, 7, 13 trimethyl, 11 propyl. Run it all together with tetradecane. I know this has been a long solutions video. We got one more to go, just stick with me. Okay gang, last problem on say my name, IUPAC alkane nomenclature. Alright, so if we take a look at this monster right here, remember the approach, I know you're sick of me saying this, remains the same. Find the longest dang parent chain. Okay, so if we take a look here, let's do some counting. I'm a little partial to start in this neck of the woods because going from right to left will make a little bit more sense because I don't see a lot of branching here. I see a branch at 1, 2, I see a branch at 1, 2, I see a branch at 1, 2. I don't see that anywhere over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I see 12 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Not long enough, and that's the same going to be up here or down here because it's just at this fork 1, 2 or 1, 2. So looking this way looks pretty good. I'll put a 12 up there. Kind of link these together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we do have a tie. So how do we settle this? Well, we need to see how our branching works out. So we see we have 1, 2, and 3. Branch at 2, branch at 3, and then 4, which is where we hit the middle. 1, 2, so 1, 2, and 3. So, interestingly enough, we have the same type of branching here. However, what I'm going to do, and what is the ultimate tiebreaker, is everything here, with this chain is just alkane. However, up here we have a functional group. So let's include the functional group in the parent chain. If it comes down to that, include the functional group in the parent chain. So we have 3. So we are picking this over here just because of including the chlorine in the parent chain. So 5, 6, 7, 8, 9, 10, 11, 12. Okay. I would say you'll never get put in a situation like this. Probably should have made the example a little bit more robust by making an extra, branch at one of these positions, but I would say this is how you choose it. Okay, so let's go about naming our substituents. So at this point, right, we have 2-chloro. Then I can get to my methyl, so I have a methyl here, and so I have 1 methyl, 2 on 5. That's it. So I have 3 total. So I have 3 and then 2 on 5. So 5, 5 trimethyl. Then I have 7-T-butyl. I know I drew it more like a cross, and on the worksheet it's more of like a turkey's foot, but it's all the same. 7 and then T-butyl. Remember, hyphens between T and butyl, even though they're both words, not numbers. 8. I don't have a word for this, so we will name this in parentheses, but let's do that last. And, I even forgot. At 4, so I have nothing else up here. At 4, I don't have a name for this, so I will also name this in parentheses. So let's start off with 4. 4, open parenthesis. So I find your longest parent chain. Remember, by default, that carbon will be first, the one attached to the parent chain. The longest I can do is 2, 3. And it doesn't matter if I went 2, 3 this way or 2, 3 this way. But just like we did in the previous example, we have a 1, 2 dimethyl, and our chain is 3. It's still a substituent, so propyl. Okay? And now on to 8 in parentheses. So we have 1 by default, and now remember, we either go 2, 3 or 2, 3. Doesn't matter which way, they're both the same. So we actually here have a 1 ethyl propyl. I hope that makes sense because we just have a branch on 1, it's an ethyl. Overall, we have 3 carbons, so it's a propyl. So now we need to alphabetize. So we have the C in chloro that counts, the M in methyl, the B in butyl, remember, not the T because we're not in parentheses, so it doesn't matter. The D in dimethyl and the E in ethyl propyl. So the the doing things with the alphabet works out with butyl taking first, chloro taking second, the dimethylpropyl taking third because D counts in the alphabetization, then the E in ethyl propyl, last but not least the M in trimethyl. Overall we have 12, so this is going to be a dodecane. Whoop. A dodecane. Let me pause the video, we'll have the name up, we'll give this video finally a wrap. So gang, putting the name all together, we have 7-T-butyl, then 2-chloro, the 4, and then remember dash, open parenthesis, 1,2-dimethylpropyl, 8-1-ethyl propyl, and then 3,5,5 trimethyl-dodecane. Alright, and remember, ran all together. Sorry this video is a bit long. I just wanted to make sure that you have a strong foundation for naming. If you're watching this video, that means you've thrown me some money. Thank you for supporting jOeCHEM. I so appreciate it. I hope you're finding it helpful. I thank you for bringing me along in your organic journey, in your mastery, from the beginning to the end. And I hope I'm there the entire time. But if anything, I hope to see you all in the next video.